Yeah, and with that, I'd like to introduce Daniël van Doorn. Daniël van Doorn is working at Consulting Werk as an architect and consultant for DevOps solution, build pipelines, things like that. He'll have a few more words on himself when he starts. And with that, Daniël, well, thanks for your time this afternoon. Well, late evening for us here in Germany and the Netherlands, where Daniël is sitting. And yeah, have fun.
So, good afternoon. Right, so I'm going to do a live demo of building a PASOE image in a Docker container in a pipeline, and then we're going to run it as a container. The agenda will be a little bit about us, Consulting Werk, and about myself, then the live demo. I will explain the plan, the tool stack that is used, what is in scope, what is out of scope, how the workspace is set up, and what we're actually going to do. So, right, we are Consulting Werk. Here you see most of our team. We are a growing organization, so every so many months we get new members. And we are an independent IT consulting organization focusing on OpenEdge and related technology, located in Cologne, Germany, and in the United Kingdom, USA, and Romania. We have customers in Europe, North America, Australia, and South Africa. And we are vendor of developer tools and consulting services. Specialized in GUI for .NET, Angular, object-oriented ABL, software architecture, application integration. And we are experts in OpenEdge application modernization. Right, our portfolio. So we do everything OpenEdge related. We work with Telerik, the OpenEdge Ultra controls, Sitefinity, Kinvi, Corticon, WhatsUp Gold, and Camp Loadmaster. We work with the Protop database monitoring, Combit list and label, web frameworks like Angular, .NET, Java, Elasticsearch, Lucene, Amazon AWS, Azure, DevOps, Docker, Jenkins, and Gradle and Jira. And that is mostly my department. So I'm Daniël van Doorn. I'm a senior consultant at Consulting Werk. Started developing Progress in 1997. I started with version 7. Was always interested in developing toolkits, frameworks, that kind of stuff. That's the reason I started at Consulting Werk. And the last 10 years, I did stuff like technical application management, configuration management, what we now call DevOps or SRE. And then mainly with a focus on the build and deployment of OpenEdge applications. So today we are going to build a Docker image. And I set up an environment for that, and this is the tool stack. I like to be able to also give this presentation on the dark side of the moon. So I have my own local Git server. I use Gox, the Go Git server from Google. Of course, Git, Jenkins, and a Git plugin, and PCT, Docker Desktop, WSL2 and Ubuntu, and OpenEdge and OpenEdge PASOE Docker image. Yeah, we need Java to run OpenEdge, and I will do the coding in Visual Studio Code. So, always interesting to first tell what is out of scope. We only have an hour to do something, so everything PASOE security authentication is out of scope. We will not do anything with database connections. today, or database containers, or updating the security inside our Docker image on the PASOE. So with secprop updating OABL security.properties, it's possible, but due to time constraints, it's not part of this demo. Furthermore, I have some scripts that make this demo a little bit easier for me, and I will show them later on. So the plan. The plan is we have some source and we want to compile that source, create a library of that source of the runtime, and then prepare a Docker workspace and build the Docker image. Everything on top here is done in an and build file. Then build the Docker image itself. We will do in a Docker file, and the flow will be something like get something from a base image, add Java to the image, add an entry point script, create the PASOE, add the application PL, and then configure the PASOE. Right, so for the demo, I have installed a clean Jenkins, only a master, no additional build nodes or cluster, and that Jenkins is not configured, and part of this demo will be to configure Jenkins. We will set up a multi-branch pipeline with a Jenkins file, a little bit of Groovy, and then we will start building and compiling the API, assembling the Docker workspace. Then from there on, we will create the Docker image and configure the PASOE in the Docker file. And last but not least, we will run the Docker container and check the result in the browser. Yeah, okay. Right, I skip this one. I will have a look at this. We'll also show you it shortly in Visual Studio Code. So I made a simple web handler. You can find the examples for a web handler on the internet. And in this case, I just return a JSON message with hello Puck USA 2023. So this already exists. It's out of scope for the demo. This is the source which we are gonna compile, put in a library, and then put in the Docker image. So what is also out of scope is the entry point script. I once wrote a nice script in Batch that will start the PASOE. It will start to look for the Catalina.out. When it can find that, it will log that on screen. Then it will look if it can find the session log. Then it will log that on screen. And when it finally can find the agent log, it will tail that on the console. Yeah, scripts to make my life easier. I have a commit.cmd, which I will regularly use, and it does a git add and a git commit and push to my local Git server. And for running the Docker container, I have a run.cmd, which will run the Docker container. It contains the port mappings to the host, and it contains a volume mapping to the license file. In principle, the license file is not part of your Docker image. It exists outside on the host, and we map that to inside the Docker image, but that's for later. So the requirements for the Docker image. Well, we need a PASOE base image. We can download that from the Progress ESD or from DockerHub. I will be using OpenEdge 12.7, and that implies I should use the GDK 17.0.4. We will need to insert the entry point script, the start.sh. My start.sh was developed on the Windows, so it has carriage return line feed, and we need to remove the control M's to make it executable under Unix. Then create the PASOE instance and insert the progress library into the Docker container. Then update OpenEdge.properties, configure the entry point script, and expose the ports. So what is that configuration? What we need to do? Right. So if you are a little bit familiar with PASOE, you know there is something like an OpenEdge.properties, and we need to configure some stuff in OpenEdge.properties. In this case, my app name is called Hello World PASOE. That's what we are going to use. And we need to define a web handler for that. The Hello World web handler, which will display our message in the browser. And of course, to let the application function a bit, we need a ProPath. So I talked a little bit earlier about a Docker workspace. So a Docker workspace works a bit like a Git workspace, or the workspace you have in OpenEdge Studio. It can only, you have a root folder, that's where the workspace starts, and you can make subdirectories under that root folder, but you cannot go out of that root folder. So everything what we want to have in our Docker image needs to be in this directory. Then let's have a look at the workspace. So this is how the workspace more or less looks on disks. We have a build scripts directory, a Docker directory, GDK directory, and a license directory, and OpenEdge with web handlers. On the build server or in our Jenkins pipeline, it will look a little bit different. I always like to separate sources from runtimes, input from output. So we will create on the fly a work directory with an input directory for Docker. This will be our Docker workspace. And we have an output directory. And in this case, we only have the R code under the output directory. So what is in scope for this demo? Well, setting up Jenkins, creating a Jenkins file for the multi-branch pipeline, creating a build.xml to build everything, and last but not least, create the Docker file to build the Docker image. By the way, sometimes I use the word container, sometimes I use the word image. What we are going to build is a Docker image, and as soon as you run it, it becomes a container. So, time for action. Mike, are there any questions so far?
No, Daniel, we're good to go.
Okay. So, right here I have my local Git server where we will work with. And here I have my fresh new installed Jenkins. Now, first of all, we need to do some configuration, and we need to configure some tools. And well, one of the tools we need is Git, and default Git, and I have Git in my path, so I do just git.exe. That should do it. Apply. And I need an end installation, and I will not install that automatically. As you might know, end is since progress version 11 delivered with OpenEdge, so it's in our DLC directory, and I will call this DLC end, and that would be in my case C progress OpenEdge 127_64 end. Okay, apply. Then we will set up a pipeline. So I click here, new pipeline, and demo Docker PASOE, and it's a multi-branch pipeline. Demo Docker PASOE, add source, and the source is Git in our case, and I copy the URL from here. And I fill in some credentials. And I need to have discover branches should be on. And there is a polling interval, right? And we put that on 1 minute. Again, this is because it is a demo. And it's the quickest way to get something running. So in this way, Jenkins will scan the Git repository every minute to see if there are changes. When there are changes, it will start building. Is that the best way of doing it? No, not in my opinion. In my opinion, Git should trigger Jenkins to start building, because when I commit something and a colleague of mine commits something within the same minute, then I do not want to have that running in the same run. I want to have the changes isolated so that we nicely know where it goes wrong. And to continue, we will build by Jenkins file, and that is one thing we will create. So when I now do save, we see that it scans Git, it's happy, but it also complains that the Jenkins file is not found. So how do you create a Jenkins file? Well, when we would Google on Jenkins file and sample, then one of the pages we come here is on the Jenkins documentation, and there is a sample of a Jenkins file. So that's what I'm going to copy, and I'm going to Visual Studio Code, and I'm going to say new file, Jenkins file. And I put that code in. We will not have a deploy stage. We will have a build stage and something Docker stage. So now let's see. I commit this. I must say I'm a little bit. 1 minute takes too long for me. And when we now look, we see we have a demo PASOE pipeline, and we see here a master branch. For this demo, we only use the master branch. And we see a build running, and when we look at the console output, yeah, then Okay, it took a bit, but there it is. And we see now that our Jenkins file has run. Of course, it did not do anything yet, but that's something for later. So let's start build. Yeah, that's okay. Next thing we are going to do is we want to use a build script in end, and that means we're gonna put here in the steps with and then installation DLC and that's the end I just configured in Jenkins. Nicely helps us to be able to use different end installations and locations on different servers, for instance. So that's why I do not point to the qualified location. So I'm gonna execute and that's and minus F to execute the file. And I do that in build scripts and then build.xml. So now let's commit that and we can see that run. In the meanwhile, I will start with a new file and I call that build.xml. So, and it's XML. Could start with an XML header. I will just copy and paste that in. And then a project. That's how you start an end file. I give it a name. That's not so important, but we do it anyway. PASOE software. And I will give a default target to be executed, and the default is build done. If you are not familiar with and, the end dependencies works always in a reverse order. So you start at the end and then work to the beginning. But we will see that shortly. And since I have this build script in build scripts, but I want to execute it really one directory higher, I will use the base tier attribute and do one directory higher. So, and it's XML, and we must comply with that. So we nicely need a closing tag, /project, and then we need targets. And let's see, so we need a target, name is build done, and depends is nothing for now, and slash target. Yeah, that one. So, and let's nicely indent that. And I need a few of those. One more. So, and we start here with init, and in the init target, I will set up a build workspace. Then we will do a compile, and that depends on init. Then we will do a create library, and that depends on the compile. Then we will do a bundle Docker, and that depends on create library. And last but not least, build done. And let's put a message there. Build done. So then we need to compile, and if we take again the internet and Google, and we go to the site of PCT, then we have here the PCT compile part, and we need some options from that. But before that, we need to set up the workspace and initialize PCT. But let's start with setting up the workspace. Always like to clean up. As you might remember from the presentation just before, we will do everything in the work directory, and let's start with cleaning that up. So when you run multiple builds in sequence, it depends on your settings. If you clean up your workspace, yes or no, it might be beneficial to not clean up your workspace. It could give a faster checkout, but at least all the files you compile and assemble should be deleted and refreshed with every build. So that's what we're going to do. Delete there is work, and that will delete the work directory and all subdirectories. So we are directly going to recreate that directory. Work. So let's see, mkd work output. I need an input directory. I need output R code directory for our compile result. And I also need our Docker directory, but I'm not going to specify that as a literal here because I need to do more in that directory. So I'm going to put it in a property so we can reuse it. Property name is Docker dir, and location is work input Docker, and that enables us to now use this property instead of a literal. So that's dollar and then Docker dir. So that sets up our workspace. Then we need to do some stuff with PCT. I need the DLC. There would be smarter ways of doing this, but not during this demo. So I'm just going to define the property here, DLC, and location is C progress OpenEdge 127_64. That is our DLC location, and I also need the location of pct.jar. Property name is pct.jar, and the location for that is $DLC /pct /pct.jar. So, yeah, we have some PCT initialization. I'm just gonna copy that in. It will load the PCT properties and the type.properties. If you want to know more about this, look on the wiki page of PCT's GitHub. And then we can start with the compile. So if we might remember, we have here our OpenEdge and our web handler, and we have our Hello World Hello World class. And we need to compile that. Well, for this demo, it's only one file. You can imagine in real life that will be a complete Observer application. So we need PCT compile. And then we can have a look here at all the options of PCT. I know we will not use a graphical mode. We will use the destination directory because I like to separate input and output. We need a file set and a pro path. So let's start coding. Yeah, so I will put that there. First, close my /pct compile tag. And then we can start typing here. Graphical mode is false. In general, you compile in TTY for an observer. Destination directory is a work output R code. That's where we're going to compile to. And the PCT compile needs a DLC. That's DLC home, and that is then $DLC. Right. So then we need a file set to tell PCT what it's going to compile. So file set, there is OpenEdge, includes is ***star.cls. That'll do. We only have class files in this case. And we need a pro path, of course, else we can hardly compile in OpenEdge. Pro path, and we close that. And in that pro path, we can have one or multiple path elements. We need one path element there. No, path is $DLC /TTY/netlib /openedge.net.pl. And that should compile our source. We will see later if it actually works. For now, we continue. So the next thing we wanted to do was a library, and there is here the documentation for PCT library. So what we want to do is we want to build a PL out of the results in work output R code. And we see here some samples, and let me type that. Right, create library. So it's a PCT library. Destination is, and to keep it easy, we're gonna generate this PL directly in the Docker workspace directory. That makes sense because we need to import it in our Docker image. So $docker.dir /application.pl. We again need a DLC home variable set to $DLC. And we need to close this /pct library. And then we need a file set. And file set, there is So work, output, R code, and what we will include is everything .r. So include name is *****star.r. By the way, ** means that it also should go into subdirectories to find there any runtimes. We will not have that, of course, with our one runtime. We do this anyway. There's file set to close the tag. And we have built a library. So let's just have a look at what we have now and how it functions. So I push it to my Git and I click on scan multi-branch pipeline now because I cannot even wait for the minute 27. There it is. And we have an error in our build.xml. But we see at least that build.xml is already executed from our Jenkins file, so we are in the right direction. And what did I miss? Oh, nasty. Okay.
Daniel, after include name, you need to have a slash and a closing caret.
Yes.
One line below.
Thanks. And in the meanwhile, we will continue with bundling the stuff for the Docker file. Let's see. So in our Docker directory, we have a start.sh. We will make there a new file called Docker file. We will not do anything with that yet, just put in a hashtag. So, and then at least I have something to copy because I would like to prepare my Docker workspace. And that means I need to copy stuff from various places in our Jenkins workspace to the workspace root of Docker. So copy file is docker/docker file. And to there is my $docker there. Next thing we need to copy file is GDK, and I'm really not going to type this. Let's see. So C, USA, source, PASOE, and GDK. That one, F2, copy. Thank you. So GDK/that, and that should also go into the Docker there. Then we need the entry point file. So copy file is a docker/start.sh, which will start our PASOE. And do I still have that? Yeah, I have it. So, and that should make our build script complete. Let's see if I made any mistakes. And we will resolve those. Okay, so it ends with build done. If there was an error earlier, then it would have failed. So then it would never have reached this message. So we're on the right track. We're now gonna build the Docker file. So I put in some comments first. Docker, typing is hard. Docker file for PASOE demo image. And in a Docker file, you can use a few commands. It's actually fairly simple. Don't know if I have it open. Yes, there is something, best practices for writing a Docker file. You can look in that yourself after the presentation on a later moment. But we will need to start with a base image, the image on which we will base our image. As shortly said, I downloaded that from the ESD, and if I will do a Docker image ls, we will see here the store.progress software.pasoe 12.2.7, and that's what we are going to use. And we can do that with the from command. So store progress software slash PASOE, and the tag is 12.7.0. So that makes the base image. Then we have to add Java to our image, and to add Java, we need to become root, and there is a Docker command to do that. There is the user command, and we root, and then we do the add command, and the add command will import a zip or a tar.gz, and it will automatically extract that to the host, to the image. So I'm not going to type that name. That's the GDK 1704 for Linux, and we're going to put it in Azure. Now, that's not where we finally want to have it, so we will do some Unix commands to put it in the location where I want it, and make it executable. Slash Azure GDK dash 17.0.4.1 plus 1 slash Azure Java, and that is then we want to make that executable, and I do that in the ugly way. So change mod 777 slash Azure Java bin Java. Yeah, I copied that a few times. So make the bin directory executable and the Java directory too. That gives us Java inside our Docker image. So the next thing is our entry point script. Deploy entry point script. As said, the thing was developed under Windows, and it has nasty carriage return line feed. We need to remove that. I'm gonna do that in an easy way. Move. Should copy it first before moving, right? copy start.sh. So in the build script, we copied the start.sh to the Docker workspace. We can now just locate it without specifying any directory. And we will copy that to /pscwrk, the progress working directory. And I will move the pscwrk start.sh to start.txt. Now I could use a command like undos or something. I could also have arranged it in Git, but I don't want extra stuff in my image. Lucky in every Unix version, there is still the good old set command. That was the streamed editor function of VI when you are familiar with the bit older Unix, and that's what we're gonna use to remove the Control M. So run set and as replace, and we want to remove the carriage return. We need to escape forward slashes, right? And we want to remove that in this file and output that to the .sh. So that removes all the nasty MS-DOS Windows stuff. And of course, then we need
Daniel?
to make it, yeah.
I think you want to remove the move.
Yeah. Right, and then of course we have to make it executable. Say mod plus x /pscwrk start.sh, and we should have a running entry point script. Now, last but not least, let's start with creating the PASOE. Oh, that deserves 3 hashtags. Creating PASOE. And we don't want to do that as root. We want to do that as the designated user and progress in the base image which we are using. Create a user for that PSC admin, and we're going to change to that user PSC admin. And we're gonna set first some environment variables which make our life a little bit easier. So env PASOE, and that will be in /pscwrk hello world PASOE. And we need another one, env uproot. That's where we're gonna deploy our application or our library, and that's in $PASOE / OpenEdge. We use the default location. So then it's time to execute our tcmon. But we first need to set some properties, some shell variables like the DLC and Java home. So export DLC is /psc DLC, and yeah, Java underscore home is /user Java. That should do it. And we want to continue the statement. So we do 2 ampersands and a backslash. So $DLC servers PASOE bin tcmon.sh. Create, and let's keep it as standard as possible. So 88 8820, HTTPS on 8821, and shutdown port on 8822, and we want that in the location PASOE. So that now creates our PASOE. Then let's deploy our application. And we do that with a copy from the host into the Docker image. I did not say that. And it was application.pl. And we need to copy that in $uproot. Right. I'm not sure about those. So now comes the fun part. I will copy this because I need it a bit more. We are going to use OE prop to update, first of all, the pro path. I'm gonna copy that in. It's a little bit faster. So my app is called Hello World PASOE, and the pro path is uproot application. So that was in our PSC WRK Hello World PASOE OpenEdge, the application.pl, and then we need openedge.net.pl and the core PL. Right. So I need this again. I need to define the web handlers. I'm also going to use OE prop for that. And I will copy it in. So. And the most important one is this web handler one, and that points to our web handlers.hello world web handler. That's the class we compiled. And the REST endpoint is hello world. Now, then we are already pretty far. So we need to tell Docker that we have an entry point script and that Docker should use that whenever starting the container. So entry point, square brackets, and that is then PSC WRK start.sh. And we need to expose the ports. We just defined here 3 ports. We need to expose those. So expose 8820 and 8821, 22. So, okay, we can already commit this. Now, then in our Jenkins file, we had a part with building it, but we did not have anything yet for Docker. And here I want to work in the work input Docker directory in our Docker workspace root, so to say. So I tell that to the Jenkins file, work, typing is hard, input Docker, and so, and let's do an echo building Docker image. And we use bot, so Docker build in the current directory -tech, and we call that perk PASOE, and I want something to not overwrite that tag all the time. And if we would look into some Jenkins configuration, then Jenkins has the build number available. And that is what we are going to use to uniquely tag our Docker image. So PASOE colon right dollar build underscore number. So that should be it. Well, from here on, it's try, resolve any possible errors, and then we can run it. So let's see. Did it already find something? 59 is a bit early. Come. Right, number 8. So it's executing the build script, and it crashed on something. Interesting. It complains about the Docker file. The Docker file is copied. Let's have a look here. I can look into the workspace, right? Workspace. Right, so work input Docker, that's not a lot. So let's have a look what went wrong. We compile to the Docker dir, the Docker dir, property Docker dir, work input Docker, work input. Ah, right. Works so much better if you put the dependencies in. And it actually does something. So, okay, build done depends on bundle Docker, create library, compile, and init. That looks better. So we're gonna try another commit, push, kick the pipeline. So we see here Docker executing. We see that it loads from the PASOE 12.7.0. It adds the start.sh. It adds Java. And currently it's working on the tcmon create. Right, and it says we have a success. Now, let's have a look here, Docker image ls, and we see here that we have a perk PASOE made 12 seconds ago. As I said, I have some tools to make my life easier, and I will do here run 9. 9 is the build number and the tag for our Docker container, and this will start the container. So here we see the startup script. It's waiting till Catalina starts. It will log the default console. Now it's searching for the agent log. And here we have the agent log. And that means that everything should be online. So if we would look in the run command, these are the ports that are mapped. And that's what we can access. Well, when we want to use a web handler, that goes via the web transport. So we always need to supply web. So it will be something like localhost port 22001/web/hello world. And that gives us hello remote PUC USA 2023. Right. So that was my live coding demo.
Well, I think it was more like a roller coaster ride through Jenkins files, Docker files, ART files.
Oh.
There's been no question in the chat so far. If you have questions, please put them in the chat and we can deal with them. Daniel, could you please go to the next slide?
Mm-hmm.
I'd like to finish with a couple of announcements. Not sure if you've heard about this. After a couple of years of absence, the PAC Challenge Americas is coming back. Tom Bascom and the other members of the PUC committee in the United States and Canada are organizing this conference. It will be held in November, from the 13th to the 15th, in Burlington, Massachusetts, just right around the corner of the new Progress headquarter location. Well, and as typical for the PAC Challenge Americas, just focused on OpenEdge, purely technical content, and well, plannings are currently going on, probably between 50 and 60, maybe even towards 70 technical breakout sessions over these 3 days. I think a great occasion to get informed about the latest and greatest of OpenEdge. Daniel, next slide, please.
Hang on.
This webinar today was, well, for now, the last one of a series of webinars that we've held over this spring and summer season. Started with webinars mostly held by either myself or our colleague Peter Judge. First one was about mysteries of pro dataset and temp tables, especially passing them as parameters. Next one was about how can we answer the question what our app server is doing all day long? How do we get nice statistical data about what requests are executed, how long they take, and which overall loads they're doing. Peter then did a webinar on ABL logging, how you can integrate very flexible logging into your application that does not require code changes. We then did a webinar on how to integrate Office 365 as an authentication system for OpenEdge GUI applications. And a couple of weeks ago, I introduced the new capabilities of OpenEdge 12.7 to use .NET Core as an alternative to the .NET standard framework. All those webinars have been recorded. You can find the recordings on our website. The webinar today about Docker is currently being recorded, and it should be on the website probably tomorrow or no later than Monday. I guess that's a lot you might want to look into to do this roller coaster ride a second time. And the next slide, please. And we'll now have a short break with these webinars. Next month, as the challenge here in Europe, followed by the OpenEdge World Tour in Las Vegas. So live events that will keep us busy. And in November, there's a PAX Challenge Americas, and our plan is to continue with offering webinars like this one after the PAX Challenge Americas, so maybe just before Christmas, and then resuming in January. Okay, and with that, I think Daniel now has this question slide. I still don't see any questions in the chat. So I guess we can conclude at this time. Thank you for joining this webinar this afternoon. Daniel, thank you for driving us at rocket speed through making a functional Docker image.
Right.
And
yeah, I want to add there, if somebody wants to have the sources, the code samples or whatever, please email me and I can supply those.
Okay, thank you for that. And with that, I think it's time to say goodbye.
Goodbye.